After around 2.5 years on the surface of Mars, the Ingenuity helicopter has just reached a new milestone. Days ago, it completed its 57th flight, contributing to a total combined flight time of over 100 minutes. This came after a few scares in the prior months when Ingenuity was not responding and forced into a low power mode. At this point, Ingenuity has surpassed its expected mission lifetime not by months but by years. This is a very big deal, considering this mission isn't a one-off, but supports NASA's upcoming plans to send an additional 2 helicopters to the Martian surface. The recent milestone only supports NASA's plan and the design of these more powerful rotorcraft. The continued operation of Ingenuity has also helped keep the Perseverance rover on track, which is still in close proximity. All this being said, the helicopter has a challenging journey ahead with more flights scheduled and complex terrain in the area. Here I'll go more in depth into Ingenuity's recent milestone, its current condition, NASA's new Mars helicopters, and more. NASA's Ingenuity helicopter has now flown for a total of 102.4 minutes on Mars. The 4-pound or 1.8 kilogram Ingenuity flew for the 57th time on September 3rd, covering 713 feet or 217 meters of ground on a flight that lasted 129 seconds. NASA's Ingenuity Mars helicopter acquired this image using its high-resolution color camera. The camera is mounted in the helicopter's fuselage and pointed approximately 22 degrees below the horizon. Originally, Ingenuity was meant to show that aerial exploration is possible on Mars, despite the planet's thin atmosphere. The helicopter aced this mission after a month-long 5-flight campaign. NASA then granted an extension, during which Ingenuity is serving as a scout for the Perseverance team. NASA was quoted saying, "Even before the end of Ingenuity's primary mission as a technology demonstrator, the helicopter showed that it could provide tactical and scientific scouting for the Perseverance mission. In practice, this hasn't always been possible, but Ingenuity has indeed proven its worth on more than a few occasions over the course of the mission," they said. For example, on Flight 48, Perseverance planned to spend at least 2 weeks at the 10B region, followed immediately by an exploration of 2 other planned locations west of the rover's location. Scientists have a general idea of the terrain and options on Mars, but there's also a lot they don't know. When planning for these regions, they asked for advanced reconnaissance of the area from the Ingenuity team. Eventually, Ingenuity's 48th flight produced a host of aerial images showing the exact area of interest at a resolution several orders of magnitude better than anything prior. All of these images were downlinked to Earth and provided to rover planners and scientists a full 2 weeks before the rover would reach this area. It's also important to point out that the Ingenuity helicopter needs to stay relatively close to Perseverance in order to operate. Specifically, the proximity between the two determines the telecom strength. Ingenuity sends signals to the rover, which then communicates with Earth. In the past, this has caused a few issues when Ingenuity lands behind a large hill or Martian mountain. This can block the signal and stop communication with the helicopter. However, in the 2+ years that NASA has been operating Ingenuity, they made quite a few software updates to try and improve its operations. In a statement, NASA said that Ingenuity's navigation software was designed to assume the vehicle was flying over flat terrain. When the helicopter is flying over terrain like hills, this flat ground assumption causes Ingenuity's navigation software to think the vehicle is veering, causing Ingenuity to start actually veering in an attempt to counter the error. Over long flights, navigation errors caused by rough terrain must be accounted for, requiring the team to select large airfields. This new software update corrects this flat ground assumption by using digital elevation maps of Jezero Crater to help the navigation software distinguish between changes in terrain and vehicle movement. This increases Ingenuity's accuracy, allowing the pilots to target smaller airfields going forward, they said. By now, Ingenuity has not only flown for over 100 minutes in total, but an impressive 13,130 meters across all flights. Traveling this far in such a short period of time is one of a kind on the Red Planet, and why NASA is so interested in using more Martian helicopters in the future. For the past few years, and nearly the next decade, NASA's primary mission on Mars will be collecting physical soil samples and sending them to Earth. Called the Mars Sample Return Mission, right now the start of this process is already underway with Perseverance. 20 out of 38 samples have been collected, and some of them have been cached, including 16 rock sample tubes, 2 regolith sample tubes, an atmospheric sample tube, and 3 witness tubes. These cached samples were placed on the ground in a location where they can be picked up in the future if necessary. In 2028, NASA plans to launch a Mars lander with 2 helicopters as part of the payload. The lander would touch down close to Perseverance's landing location in Jezero Crater. Having collected and stored a wide variety of samples, the Perseverance rover would be the primary means of transporting samples to the sample retrieval lander, handing off a collection of sample tubes carried on board. An ESA-provided robotic arm would transfer the tubes into a sample container on the lander's rocket. However, as a backup, if something were to go wrong with Perseverance, the helicopters would come into play. The sample recovery helicopters are modeled after the Ingenuity Mars helicopter in a lot of ways. These specialized rotorcraft would be a secondary method of sample retrieval for the NASA/ESA Mars Sample Return campaign. The sample recovery helicopters would expand on Ingenuity's design adding wheels and gripping capabilities to pick up cached sample tubes left on the surface by Perseverance and transport them to the sample retrieval lander. The helicopters would take off and land at predetermined sites, or helipads, that had been found suitable and safe, and would use in-flight, map-based navigation to reach the known locations of sample tubes left on the surface. Each helicopter would follow a 4-day procedure to recover sample tubes. On day 1, they would fly to an area near the sample tube. Day 2, they would drive close to the tube and pick it up. Day 3, they would fly back to an area near the sample retrieval lander. Finally, on day 4, they would drive close to the lander and drop the tube in the workspace of the lander's sample transfer arm. The chief engineer of aerial flight at JPL outlined plans for how Ingenuity's guidance, navigation, and control system would be adapted and extended for the planned Mars sample recovery helicopters. Ingenuity's design forms the core of the new system, he said, but updates are needed to support the sample recovery concept of operations, primarily in the guidance and navigation domains. As of right now, details about a new robotic helicopter for Mars are conceptual, he emphasized, with details continuing to evolve over the next several years as the design matures. When asked how challenging the road ahead is, he said, "Nothing that we do here is easy, and this is not easy either. It's hard, but we think it is doable with effort. The primary challenge here is mass. We have very little air to work with on Mars. That immediately limits the amount of mass that we can carry. It will be a matter of adjusting and accommodating new elements to do something more on Mars," he said. He also pointed out in a quote that, "What's fairly clear is that the fundamental rotorcraft configuration and how we control it has been worked out, and there is heritage that can be relied upon. The new parts will require a lot of work, and that's most likely to change as we go along with the design," he added. In other words, Ingenuity has been invaluable in the design and mission plan for these newly upgraded helicopters. When talking about Ingenuity's performance, he said, "The first flight definitely stands out, a nail-biter. Many of the follow-on flights have new elements to them, like the new flight software to give the helicopter more capability. Some of the more recent flights have really pushed the envelope," he said. "I don't think it ever becomes risk-free, so there's always a bit of nervousness waiting for the data to come down. But it does become more routine," he said. "However, there's always the mindset of hoping all works as planned." He finished by pointing out, still, noting that Ingenuity's pre-hope for flights were just 5, the Mars helicopter exceeded everyone's expectations, and certainly mine. "The distance that it has put behind it and being used in such productive ways, that's huge," he said. In the next few months, we can hope to hear more about not only Ingenuity, but also the helicopters expected to join it in the future. Ingenuity has managed to prove itself as an invaluable asset for the Mars exploration effort. Without it, Perseverance would not have been able to utilize its time in the most efficient manner. This has also encouraged NASA to upgrade the helicopter's design and use a few of them for an even more important mission. We will have to wait and see how it progresses and the impact it has on the space industry. Thank you very much for watching.